So when I was researching Einstein's work, photoelectric effect, so then if you go analyze all that stuff, radiation comes in, knocks something out. Radiation comes in, it hits something.
Cause and effect.
So there's definitely some kind of like billiards.
Right.
There's a billiard ball reactions all the time.
Cause and effect.
So you think, all right, this is how I was like, if photon does the photoelectric effect and the complement effect, what's the graviton do? Mm-hmm. It must have some kind of interaction.
Right.
So then when I'm reading nuclear physics and they're like spontaneous emission, I'm like, that's probably it. And then I'm like reading chemistry and like spontaneous emission, and I was like, what? So I go look in chemistry and I go look in physics, and so then I research it more, and then I just come across, and it's like spontaneous emission is the absence of radiation. Let's see, it might even be the book. It's crazy. That's it. Photochemistry. This is the book.
Photochemistry.
So photochemistry.
Wow,
so
you went through some serious
and
reading.
emission. Stimulated emission,
Right.
Spontaneous emission.
Okay.
Stimulated emission, the word stimulated indicates that there's interaction between the radiation already present and the energy-rich species that encourages the later to yield up its energy.
Okay.
Spontaneous, in theory, an excited species may lose energy spontaneous, that is, in the absence of radiation field. So this goes against Newtonian dynamics.
Right. Spontaneous. There's
So
no
I
cause there. So all this presentations is based on the idea of the cause of spontaneous decay is caused by this thing.
It's stimulated now.
It's stimulated.
No longer
now.
spontaneous.
It's just no longer spontaneous. Everything
you
is
just have to
stimulated.
find the stimulant.
Right. And then when you take that idea, and your idea is to use this graviton type of thing, then all the stuff evolved. Right. All the stuff is based on the existence of graviton and what everything
reverse
is.
engineered. So just like they reverse engineered photoelectric effect
Right.
for the Compton effect, and they came up with whatever reverse engineered.
Okay.
And so I say, there's alpha, beta, and gamma.
Right. 3 kind of decays.
Now let me analyze those, because 3 spontaneous classifications. So I really couldn't relate to any of them except the alpha.
Okay.
Because I'm coming from the gravitation background.
Okay.
The reason why, just think about it, simple. If I say gravity, what's its associated?
Mass. Okay. Gravity and mass. I get that.
So when you get down to the heart of radioactive decay, which is, if I'm looking at it from gravity's eyes,
Right.
it has to do something with mass.
Right.
So you're going to go and you're going to get into the heart of alpha, beta, and gamma.
Mm-hmm.
Beta, that's a whole thing. But alpha, I can deal with that one. That's
Okay.
So then it's like, when you get to the details of it, it's like once anything reaches this mass,
Okay.
no matter what,
All right.
it radiates alpha decay.
So in other words, it's going to never pass this critical mass and get heavier because it's always going to have some sort of decay.
But it has to do with mass.
It has to do with mass.
So it's like you get past this 206.
That's the magic number?
206.
Okay.
206 is a combination of protons and neutrons, 206.
Okay.
If you want to, technically it's 82.
Okay.
From the proton world.
Right. So the critical mass, atomic mass, is protons and neutrons, is 206.
206, 82 for protons.
Right, 82.
So
that's
anything above 82,
that's lead.
it decays.
Right.
Anything above 206 decays.
Right. Lead. So lead is the base.
You see, but mass. Like lead is the ground.
Right.
Is the base. But mass.
Right.
You see what I'm talking about?
Sure.
Because there's no two ways around it. Mass. You follow me? What I'm saying or no?
Right. So any atomic mass greater than 206 is going to have some sort of decay spontaneous at some point.
Only alpha.
Only alpha decay.
I mean, it's going to have beta and it's going to have gamma.
But you're talking about alpha.
Adding alpha now to it.
Right. Alpha decay.
Because there's no such thing as alpha decay before 206.
Right.
So all of a sudden it's like, whoa. 206 is a mass.
Now, why is 206
anything
such a...
above 206 mass radiates. Anything below is like stable. Mass is the most important thing. You look at the math right here. You have inverse square electric, inverse square radiation, inverse square gravity.
Okay.
So, which one has mass in it?
Gravity.
Right here, mass.
Right.
Gravity.
Right.
This one, radiation. This one, charge.
Right.
Inverse square electric point, charge.
Right.
So charge, and this one's mass.
Right.
I know this. This equation
Right.
is mass.
Yes.
So you come up to a certain mass, it radiates. Below, it doesn't. So that has to do with gravity, in my opinion.
Okay.
So that's why I started the investigation.
All right.
Because this gravity has to do with mass.
Right.
And the spontaneous emission has to do with mass. It comes to a critical mass. So it's like a photoelectric effect.
Right.
Graviton comes in, knocks an alpha particle out. Photon comes in, knocks an electron out.
Right. Except this time as a graviton comes in.
Yeah, graviton comes in, knocks the alpha particle out. Photon comes in, knocks the electron out.
Right.
It's called the inelastic collision.
Okay.
Versus elastic collision
Right.
is the Compton effect.
I see. Very good. All right. Well, based on this idea, then, I guess this is how this presentation kind of came up, right? This is how it all started. Well, let's start with the first page, actually. It says here, Dummy's Guide to Dark Matter. What the hell is that?
If it's so dark, why can't we see it?
Right.
If there's so much of it, why doesn't it affect us? What would light matter be? How dark is lead? Lead's electromagnetic susceptibility.
Okay.
Investigate relation between high-frequency gravitons and alpha decay simulation. For every one atom, lead atom, how many hydrogen and helium atoms from parent atoms series decay? So the world right now is all focused on hydrogen and helium.
Yeah, I don't know why that is, but you're right. It's
So-
all focused on periodic
hydrogen
table 1 and
helium,
2.
Hydrogen and helium, hydrogen and helium. Now, in reality, hydrogen and helium is a byproduct for uranium to get to lead. That's it.
For uranium to get the lead because of the decay.
And in order for uranium to turn into lead,
Right.
you have hydrogen and helium.
So what
Beta
you're
decays hydrogen.
So maybe the start of this universe, I guess we go back then, was more heavy elements, maybe more uranium that eventually came to lead, and that's why we have a lot of hydrogen and helium in this world. Is that a possibility? Is that what you're saying?
Yeah, that means there was a lot of decay.
There's a lot of decay happen. You know, it kind of makes sense that in terms of the Big Bang Theory, I guess Big Bang says everything was very condensed or very heavy, and then maybe a lot of decay happened when there was a lot of condensed stuff at the beginning.
Yeah, well, that's
which is
what
why
they
we
say.
have helium and helium.
They say that the antimatter and matter annihilated,
Right,
and then they say when it annihilated, it created this,
right,
which is like a perfect, like on the edge, 51.
right. There was
How?
more matter than antimatter.
Yeah, or
which is
whatever,
this.
whatever the imbalance is.
Okay. So I can understand this then in terms of, for every one lead atom, how many hydrogen, helium? All right. What else is this?
So you reverse engineer.
Okay.
You start, say, for every lead atom, how many hydrogen and heliums? So you say, okay, lead. You add hydrogen and helium, it becomes...
The next element.
Yeah. You add that, next element. Now,
Reverse engineer.
where's the top? Where's it capped out?
Right.
When we study history, there's no cap.
Right.
There's an unlimited amount of energy.
Right.
So you have to reverse engineer, and that's it. You
Okay.
focus on, and you keep this, and everything else is unlimited.
I see.
This is it. If you start off at uranium or plutonium or thorium or they can make man-made synthetic elements that go 120 or something,
Right.
right? Instead of 92.
So the lowest level you come back down to is lead then ultimately in terms of decay.
So then you just focus on lead and you keep on lead, because the other ones you don't know.
Right.
And it's like the temperature 1 and temperature 2.
Okay.
We don't necessarily know the highest temperature in the universe,
Right.
but we know theoretically the lowest, 0.
Absolute zero, yes.
So in this case, we don't know the highest, element, but we know the lowest.
Right. In this case, lead.
Lead. When we're talking about this.
Okay. All right.
Because then we start talking about iron or gold or silver or carbon or oxygen. That has nothing to do with this.
Mm-hmm.
So I went to tech. They don't want to do anything because they said all my stuff they can't publish unless it has something to do with dark matter.
Okay.
So then I was sitting there and I was like, but I do have a lot of lead.
Right.
And then he's like, huh? And I go, I have a lot of lead.
Mm-hmm.
So like, in all what we talk about, there has to be a lot of lead out there.
Right.
And then he's just like, a lot of lead? And I'm like, yeah, in the stars. And he's like, not going to happen.
Right.
And I was like, what do you mean? And I go, in order to have this much hydrogen and helium based off of everything we know, there has to be a lot of lead.
Right.
Otherwise, the hydrogen and helium are produced something else.
Right.
And it's not produced from radioactive decay.
Right.
So how do you get hydrogen and helium? Radioactive decay. There's no other way we know.
Right.
You pick up this earth, you look at it in a microscope, you segregated this, and you analyze each element, like Marie Curie did.
Right.
And you come up with a set of principles of radioactive decay laws.
Right.
Once it's past this much mass, it radiates radiation spontaneously.
Kind of makes sense because the theory of the Big Bang is everything was so condensed that you got to have a lot of heavy elements out there, and then these heavy elements greater than, you say, 206 start decaying, and the end result is hydrogen and maybe helium. Is that where you're coming from?
No. Hydrogen and helium are
from the decays.
Are byproducts from parent atoms. There's 4 series decays. There's like 206, 207, 208, and 209.
Right.
They're all pretty much
they're all decay.
Isotopes of lead.
Right.
So lead 206, lead 207, lead 208, and lead 209.
The differences are just more neutrons?
Yeah.
Okay.
So you have lead, 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 lead.
Right.
Now, they're all chains. This is a big chain. And then up at the top of this one might be like thorium-332.
Okay.
232.
Okay.
Might have
isotope.
Uranium-235.
Right.
Uranium-238.
Right. All isotopes.
Yeah. But they're chain series.
Okay.
And I could pull them out.
No, I get it. So ultimately, the decay of these different isotopes is ultimately helium and hydrogen.
You have helium and hydrogen in order to get to those. So here's a heavy element, here's lead. In order to get to here, like this is the alpha and omega,
right?
The beginning and the end.
Right.
You
have to have a decay.
So at the end is the lead.
Right.
So it's easier to reverse engineer because you don't know what the cap is.
Right.
We know the bottom.
Right.
So we reverse engineer that way.
Right. Well, it seems like the idea when we get into black holes is things become more dense and dense and dense, and ultimately when you have stars out there that are heavier and so dense in the middle, that the heavy elements ultimately must decay into hydrogen and helium, which is why we have a lot of hydrogen and helium in this universe.
Yeah, but remember,
reverse engineering.
The heavy elements still exist.
Right.
So you have like uranium, and it goes to lead, and then in that process, a lot of hydrogen and helium.
I get it.
So then you have lead and hydrogen and helium.
Right.
At the end of time or whatever.
Right.
If you were just be like, the end of time is right now.
Right.
The end of time for what? The end of time for nuclear decay. Right. All right. The end of time for nuclear decay. All heavy elements above lead turn to lead, and you have hydrogen and helium more.
Right.
Which is important.
Right. So I guess at the end of the decay process, we're going to get maybe a lot of hydrogen, a lot of helium, a lot of lead, but a lot of elements between helium and 206. Is that a good number?
Yeah, because
but it'll be a lot less compared to hydrogen and helium, of course.
Well,
but oxygen is still going to exist.
Anything below
206.
Anything below 206 somehow
it's still going to exist because it's stable.
Yeah, but there's a whole other
science behind this stuff.
I'm only giving one thing.
Right. That we need to talk about dark matter in order to be able to publish something, which is why you were thinking about lead.
Right? Well, because then he starts talking about matter.
Okay.
And then I was just like, I didn't tell you this before, but a part of all my work, there has to be a large amount of lead out in the universe.
Okay.
And then so he's just like, you just threw an anomaly out.
Okay.
He's like, even what you just said.
Right.
Like, it would be so hard to disprove what you said.
Right.
He's like, you'll have people sending out satellites forever.
Right.
He's like, how can you even detect lead out in the universe?
Good
and
question.
I said, by gravity.
By gravity.
And then, I said, or if it's heated.
Okay.
Because it's going to have a black body radiation spectrum.
Ah, that's good. That's good, because who knows out there? I mean, yeah, you can heat up lead.
Gravity or hot lead.
Right.
And hot lead is above zero, and everything is above zero.
Right.
There's no absolute zero lead.
Right.
So you will be able to detect it.
Right. Black body radiation.
Spectrum. That's where it's heated and emitting hot, like heat.
Right. Okay.
So.
And can I assume that the black body spectrum being emitted by lead is different from other elements, so we could determine
they've already said it. There's lead stars now. And when I presented this, there was no lead or uranium stars on the market yet.
Okay.
And then, like 4 years later, they discovered
lead stars,
lead and uranium stars.
I remember reading that. Now, do you think there's enough lead out there to account for the formulas in terms of the amount of gravity needed to? I mean, they determine the amount of dark matter to create the amount of gravity to hold the galaxy together? Could that be all lead?
It gets complicated. Let's say you have a sphere, like a ball, solid, and it's, let's say, just to make it simple, it's only uranium-235. Whatever it is, you just give, 10 million or 1 trillion atoms. I don't know.
Okay. A sphere.
A sphere of 10 trillion uranium-235 atoms.
Okay.
Now, it starts to decay.
Right.
Half-life.
Right.
So half of it goes to the next element.
Right.
And half of it is still uranium-235.
Okay.
Then half of that uranium-235 becomes half.
Right.
And then half of that other one becomes half, it goes to a different element. So anyways, it starts to trickle down, decay process.
Right. At end of time, what happens to this ball?
And it's liquid.
Right.
Liquid. The reason I'm saying liquid is because then it means that everything's moving.
Okay.
Because if it's solid, it doesn't move. So, the heavy elements are going to be in the center of the sphere.
Right.
And the lighter elements are going to be on the outside.
Okay. All right. If it's liquid.
Yeah,
and it's going to be liquid if it's hot. I mean, like the center of our star is liquid.
Okay, so heavy elements are in the center.
Right.
Lighter elements are on the outside.
Right.
Just by mass, gravity.
Sure.
So, as you produce more lead,
right,
it'll be on the outside.
Right. Liquid lead is going to go to the outside.
It creates a crowning shield effect.
Okay.
The lead shields the inside.
Right.
So you can't even see what's inside either.
Wow. That's amazing. Yeah, that's right. How do you penetrate that to determine what's inside? That's true. I mean, our star, our sun, is liquid. Now, how would you actually try to figure out what's inside? Any ideas? I mean, I like your idea, but how would you go further?
It's called the crowning shield effect.
Right. Now,
when you wear a crown?
Yes.
It's like, the crown is like the outside?
Right.
Crowning shield.
Now, did you just come up with that, or did that exist before? Crowning shield effect.
No, I did.
You did.
Crowning shield effect.
I see. If they discovered lead stars, the reality is
they actually found crowning shield stars.
Right. Now, in this understanding,
dude, that's no wonder there's so much missing mass.
Right. That's true. Because maybe the crowning shield stars, where the outside is lead.
You don't even know.
Could be so heavy on the inside.
You don't even know if it affects gravity either. You don't know if it weakens gravity. You don't know. I don't know anything yet. We're too immature. We don't have. I don't have enough data to say.
Got it.
If the lead with this much weakens gravity or not.
That's true. Because if you have a crowning shield that is lead, the inside could be so much heavy elements, we don't know, that it could account for the gravity, which makes up the dark matter. We don't know. Dude, that is true.
I'm saying, man.
That is true. We don't know. Because if they have lead stars, they're not pure lead. The elements inside, if it's a liquid core, could be so heavy, whatever that is.
But the point is,
it creates a lot of gravity.
The elements are inside.
Right.
The lighter ones on the outside.
Right.
And it turns out lead is lighter. It creates
the crust.
That's why I was even saying, like the icing on a cake.
Right. I get it.
You can't even see inside the cake.
Which also means that a lead star that they detected could be gravitationally heavier than a pure lead star, because the inside could be much more heavier elements, which has a much more heavier gravity. Is that possible?
But then you can have the lead that weakens the gravitational force, and then dude, it just opens up so much.
Well, we know that based on your idea, the heavier elements have to be inside the sphere.
No, but I mean, okay.
Which makes gravity stronger.
You know, when they go in orbit, right? They have they go and they put like water,
right?
And like it just sits there and it's like in a globe,
right?
Like, oh, look at it, or whatever. You know, you've seen that in space, right?
Sure.
I mean, they can even whatever. I mean, I don't know how. You just leak a little bit of liquid out, and it just forms a ball.
Right.
I think they even did like fuel and then lit it on fire, and it was like a burning ball.
All
right. So
gravity attracts things together in space into a ball.
So in the center, the heaviest element will be.
Makes sense.
So you have uranium in the core.
Right.
And then on the outside, lead.
Right.
So now you have a lot of heavy elements, and then they decay and they form lead.
Right.
Now the lead shields it from harmful radiation, shields it from both ways.
Right. So the radiation on the inside from elements can't get out, and the radiation on the outside can't get in.
That's why you have supernovas at one point.
Supernovas. Why is that? Because the
lead built up to a certain point.
Maybe the radiation built up to a certain point on the inside of this lead crusted sphere
that not enough radiation is getting out.
Right.
And
that's where you get pressure and temperature. So maybe as the amount of radiation increases due to the amount of decay going on of these elements inside this sphere,
not enough can get out.
Not enough can get out. Temperature builds up and then supernova. That's I've never heard of what a cause of a supernova is, now we do.
Have a possibility.
A possibility.
No, but you see?
No, I get it. I know. I get what you're coming from. Now you are able to talk about dark matter.
There's no difference between lead and dark matter at this point.
Right.
And then that's when we wrote this.
I see.
I wrote lead and dark matter.
Right.
Lead, no electromagnetic radiation. No electromagnetic radiation.
Right.
Gravity, yes.
Gravity.
Stable, yes.
Yes. But you're right, I like this idea. Lead and dark matter, both no electromagnetic radiation. Yes, they both have gravity, and both they are stable. Okay. Well, I want to end our talk over here because I think that was very enlightening. So what I'm going to do next is conclude it right now.